Dear students, let's start remaining part of electrostatic. Now, some numerical problem. We have the quantization of charge Q equal to Ne. Now some problem solved on the basis of quantization of charge. Now a conductor has positive charge (11.2 into 10 to the power minus 19 coulomb). How many electrons excess or short than normal state? Here the positive charge is given Q equal to 11.2 into 10 to the power minus 19 coulomb. For the quantization of charge, we know that Q equal to Ne. Now, N is the number of electron or protons, that is, N is here taken the proton. Now we can write Q equal Q by E. E is the smallest unit electronic charge. We know 1.6 into 10 to the power minus 19 coulomb. So we can substitute the value Q equal to 11.2 into 10 to the power minus 19 by 1.6 into 10 to the power minus 19. So cancel 7. Number of electrons, here number of proton is here 7 because it is a positive charge. So therefore the number of sort of electron is 7. Then another problem. Calculate charge on alpha particles. Calculate the charge on alpha particles. Alpha means helium particle, we know. Alpha particle means helium. Helium atomic number is 2, means either number of electron or proton. Therefore, we have the number of electron is 2 here, because we can represent the atom ZA. Z is the atomic number, A is the atomic weight. That means here Z means either number of electron or proton. Here given N equal to 2, Q equal to Ne. N is here 2 into E. E means electronic charge 10 to the power minus 19 coulomb, or charge is helium particle 3.2 into 10 to the power minus 19 coulomb. Estimate the charge of 100 gram of water. Estimate total charge of 100 gram of water. 100 gram of water. We can calculate the total charge on 100 gram of water. Now, water means we know H2O. H2O. Here the total number of oxygen and hydrogen. The atomic weight here, hydrogen is 1 and oxygen means 816 and hydrogen H11 H2. The total weight is here 16 plus 2, that means 18 gram of water contains number of atom is equal to 6 point, Avogadro's number 6.023 into 10 to the power 23 number of atoms or molecules. That means 100 gram of water contains the number of atom is equal to 6.023 into 10 to the power 23 by 18 into 100. This is the number of atoms or molecules. Each atom contain the how many electrons? That means oxygen has 8 and the hydrogen here 2. That means 10 each atoms contains the number of electron is 10. Therefore, the total number of electron is equal to 6.023 into 10 to the power 23 into 100 by 18 into 10, because each atoms contains the number of electrons. Here the total number of atomic number means number of electron or proton. This is the number of atom. So we have the total number of electron. So the charge is equal to charge Q equal to N. N is here, number of electron is here 6.023 10 to the power 25 26 by 18 into the smallest unit charge, we know that 1.6 into 10 to the power minus 19 coulomb. So we can solve this. We have the total charge on the 100 gram of water. Now, Coulomb's law. Coulomb's law. What is Coulomb's law? It has the statements. From fundamental law of electrostatic, we know that the like charges are repelled to each other, unlike charges are attracted with each other. Means that if the two charges, there should be a force of attraction or repulsion. According to the Coulomb's law, the force of attraction or repulsion between two charges varies directly proportional to product of their charges and inversely proportional to square of the distance between them. According to the Coulomb's, it states that force of attraction or repulsion between two charges directly proportional to product of their charges and inversely proportional to square of distance between them. The direction of a force along the line joining between two charges. So, Coulomb's law has statement, it states that force of attraction or repulsion, it depends upon the nature of two charges. If the two charges are similar of nature, therefore the force between them is repulsion, and if the two charges are dissimilar of nature, the force is attraction. The force of attraction or repulsion between two charges directly proportional to product of their charges and inversely proportional to square of the distance between them. This is the statement of Coulomb's law. If the two charges, let two charges q1 and q2 are separated by distance r, so according to Coulomb's law, the force of attraction between them or repulsion between them directly proportional to product of the charges q1 q2, and F is inversely proportional to square of the distance between them. This is equation 2. Combining equation I and 2I, we get F is proportional to q1 q2 by r square, and F is equal to taking some constant beta q1 q2 by r square, where beta is the proportionality constant, where beta is proportionality constant. This is the scalar form of Coulomb's law. Here beta is the proportionality constant. The value of beta depends upon the two factors. It depends upon nature of medium, second, system of unit. The value of beta depends upon the nature of medium in which the two charges are placed and the system of units also. Now, the value of beta in SI system, beta is equal to 1 by 4 pi epsilon naught when the two charges are placed in air or free space. In free space means air. In any medium, any other medium, the value of beta equal to 1 by 4 pi epsilon in any medium. So therefore, the force, Coulomb force, we can write substituting the value 1 by 4 pi epsilon naught q1 q2 by r square in free space. f equal to, that is f0, f equal to 1 by 4 pi epsilon q1 q2 by r square in any medium, in any medium. Here epsilon naught, beta is the proportionality constant, means 1 by 4 pi epsilon naught is also a constant. The value of epsilon naught, value of epsilon naught, epsilon naught has value nearly equal to 8.85 into 10 to the power minus 12 coulomb square Newton universe meter to the power minus 2. This is the value of epsilon naught. If the substituting value of epsilon naught, we have nearly value 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. Then in CGS, beta equal to 1 by k, where k is the dielectric constant, where k is dielectric constant. For the different medium, the k value of k is different. So k equal to 1 in free space means air. So beta equal to 1 in air. F is equal to Coulomb force equal to, we can write Q1 Q2 by r square in free space. F equal to 1 by k q1 q2 by r square in any medium. In free space, substituting the value of beta, the F0 means electrostatic force or Coulomb force in free space q1 q2 by r square, and in any medium F equal to 1 by k q1 q2 by r square. Epsilon r is the relative permittivity. Relative permittivity. Epsilon r is same as the k, dielectric strength or dielectric constant. Epsilon r is equal to epsilon by epsilon naught, means it is the ratio between permittivity in the medium to the permittivity in free space. Epsilon r is also a constant which is equal to ratio between epsilon by epsilon naught. That means it has no unit. It is equivalent to k. When SI system, we have the free space F0 equal to 1 by 4 pi epsilon naught q1 q2 by r square, and F is equal to in any other medium 1 by 4 pi epsilon naught k, because epsilon here epsilon is equal to epsilon naught into epsilon r. If the value putting the value of epsilon r into epsilon naught epsilon r is equal to k. Here substituting the value of 1 by 4 pi epsilon, instead of epsilon we take epsilon naught into k, then q1 q2 by r square, or F is equal to 1 by 4 pi epsilon r, epsilon naught epsilon r. q1 q2 by r square. F0 by F means electric force in the free space 1 by 4 pi epsilon naught q1 q2 by r square by 1 by 4 pi epsilon naught k q1 q2 by r square, which is equal to k. Means dielectric strength or epsilon r is the ratio between electrostatic force in the free space to the electrostatic force in the medium. Electrostatic force in the free space to the electrostatic force in the medium. This is the dielectric constant. Then